So we'll see about trapezoids in this slide set. So trapezoids are quadrilaterals. What are quadrilaterals? Any shape with four lines are quadrilaterals. The additional property is that one pair is a parallel. Okay, at least one pair of parallel sides trapezoid has. So here you can see this is parallel to this. Now the key terms, the parallel sides which are there, they are called base, and the other sides, other connecting sides are called legs of a trapezoid. So these are legs and these are bases. In real life, we can see that geometry is inspired by real life. And here we see this insects, this head area, back of the head area is a trapezoid. Now there are different kinds of trapezoids which are possible. Acute, where there is acute angle, a right angle trapezoid, obtuse angle trapezoid, and the base property of trapezoid is that a pair of sides should be parallel. So parallelogram, all sides are parallel. So this is also a trapezoid. Rhombus is also a trapezoid. Square rectangle is also trapezoid. Now we have to see about isosceles trapezoid. In isosceles trapezoid, the legs are of the same length. So this leg and this leg you can see are of the same length. So this is very, very important. Isosceles trapezoid. And this is a trapezoid where three sides are equal. Two bases are equal to one, two legs are equal to one of the base. Area of trapezoid is sum of the bases divided by 2 into h. Okay. So that is the formula for area of trapezoid. So A and B are the two bases. A plus B by 2 into h is the height of the trapezoid. This is very important, mid-segment theorem. So before that, what is a mid-segment? Mid-segment is a line which is going through the midpoints of the legs. So this is one leg and this is the midpoint, which means AE is equal to ED. And here F is the midpoint, which means BF equal to FC. Okay, so these are the midpoints, and this line which is connecting these midpoints is called a mid-segment. The length of the mid-segment, the segment connecting the midpoints of the legs of a trapezoid, is equal to average of lengths of two bases. So, which means EF, if you see EF, would be, if you add the bases AB plus DC and divide by 2, that would be the length of EF. So, EF is 1 by 2 AB plus DC. Another important property of mid-segment is that it is parallel to the bases. So EF shall be parallel to DC and EF shall be parallel to AB also. All three lines shall be parallel. Mid segment is parallel to the bases. Okay. Now we saw isosceles trapezoid. Isosceles trapezoids have legs of the equal length. So this leg and this leg, their size is same, and these two lines which are the bases are parallel, and parallel are represented like this. So what are the properties of isosceles trapezoid? The angles adjacent to the base are equal size. Okay, so this angle is equal to this angle. Okay, and same here you can see this angle is equal to this angle. So angles adjacent to each base are equal. The second property is the diagonals are of equal length. So diagonal is what? Opposite side connecting via line. So these diagonals are of the same length. We already know the sum of interior angles of a quadrilateral is 360-degree, and we also know trapezoid is a quadrilateral. So the sum of interior angles of a trapezoid is always 360 degrees. What are the interior angles? So this is, let's say, quadrilateral. So all these angles which are internal, they are interior angles. And if you add all these four, the sum shall be 360 degree.